Hello everyone, welcome to the Algebra Cosmos Part 1, Adding Consecutive Numbers, brought to you by Aspyre. This is our table of contents for today's video. We'll have a quick welcome quiz to warm up our minds before going into the key concepts involved with adding consecutive numbers. Next, we'll go through a few fun sample problems to learn how to apply these concepts. Finally, we'll be reviewing everything we learned before saying goodbye. Are you ready? Let's dive right in. My name is Jessica and I'm from South Korea, a country in East Asia. That's our flag right there. My favorite subject is math, and I'm thrilled to share this passion with you all on this channel. Before we begin, let's try a quick puzzle. What is the largest number you can make by moving one match? And here, all of these lines is one match. Try this for 20 seconds and then we'll tell you the answer. Ready, get set, go. Time's up. Now I'll tell you the answer. Here, all you have to do is move this match over here. Do you see what we will get? Let me draw it again. We get 7 d5 plus 3 equals 78. We hope you enjoyed the puzzle. Puzzles are a great way to have a little fun while getting our brains in the right mindset to do some math. The key concept we'll be learning today is finding the sum when adding all the numbers from 1 to any number. But before I tell you how to do that, let me tell you a story. This is the story of Gauss. One day at school, Gauss's math teacher asked his class to add together all the numbers from 1 to 100, assuming that this task would occupy his rowdy students for quite a while. But he was in for a surprise when young Gauss, after just a few seconds of thought, wrote down the answer 5,050. Where did he get that? The teacher was shocked at how Gauss had calculated the sum so quickly inside his head, but the 8-year-old Gauss remarked that the problem was actually quite simple. Well, do you think you can spot any patterns? Something I can see is that if we add the number over here with the number over here, so 1 and 100, we get 101. If we add the next number, the second number, with the second to last number, so 2 and 99, we also get 101. I wonder if this is true for all of the pairs inside the sum. Let's check. We know that 1 and 100 when added together is 101. And we also know that 2 and 99 when added together is equal to 101. But the next number, 3, and the third to last number, 98, when added together is also equal to 101. Do you guys see a pattern here? Let's continue. 4 and 97 when added together is equal to 101. 5 and 96 when added together is 101. 6 and 95 when added together is also 101. Same goes for 7 and 94, 8 and 93, and so on and so forth. So we have a whole lot of pairs of numbers that when added together make 101. But how do we know how many pairs we have? Well, we know that we have 100 numbers total, and that one pair is equal to 2 numbers. Well then, we know that the number of pairs that we have would be equal to 100 divided by 2 equals 50. So we have 50 pairs of numbers that sum up to 101. When we add all of them together, we get 101 times 50 equals 5050. Now let's try a few exercises to test what we learned. First up, what is the sum when you add all of the numbers from 1 to 6? Well, we can use a generalization that we just found to find out our answer. We know that the sum of all numbers from 1 to n is equal to n plus 1, which is the sum of each pair of numbers, times n over 2, which is the number of pairs that we have. In this case, n equals 6. All we have to do is plug it in to find our answer. So 6 plus 1 times 6 divided by 2 equals 7 times 3 equals 21. Let's also write everything out to see it clearer. 1 plus 2 plus 3 plus 4 plus 5 plus 6. Our first pair of numbers is 1 and 6, which adds up to 7. Our next pair is 2 and 5, which also adds up to 7. And our third and final pair is 3 and 4, which also add up to 7. Since we have 3 pairs of numbers that all add up to 7, we can confirm that our answer is 3 times 7 equals 21. Let's try the same thing for the second exercise. What is the sum when you add all of the numbers from 1 to 20? We know that n is equal to 20. So plugging it into the same equation that we have above, we get 20 plus 1, the sum of each pair, times 20 divided by 2, the number of pairs. And we get 21 times 10 equals 210. Are you guys getting the hang of it? Let's move on to some of the more interesting problems. But to make sure videos don't go on for too long, we've linked the other half of part 1, adding consecutive numbers, in the description. So make sure to go check out that second video to solve a few fun problems with me and get a summary of everything that we learned. Thank you guys and see you there. Bye!